Good afternoon to all. Once again, welcome to the lecture on digital signal processing. Today, we will discuss the next topic, that is the linear convolution or linear filtering method using DFT. Okay, once again, I welcome you all for this lecture 11th, and today's topic is on linear filtering using DFT. Now, what do you mean by linear filtering? So, most of the times, please try to understand that linear filtering is nothing but in simple job, we call it as a linear convolution. That's it. Okay, why do we call this is? See here, in input x of n, okay, then there will be a impulse response h of n. What do you perform? So that is y of n is equal to the convolution of the two input sequences, that is x of n and h of n. So this is nothing but basically a convolution, or this is going to be performed for linear time invariant system. Why we call this as a convolution? Because why we call this as a impulse response? The reason is, so when I have a system, this is h of n, or the output, this is once again input, the output is what we call it as impulse response, right? Impulse response. So what do you mean by impulse response? When the input is impulse, right? If the input is impulse, then how the system response behaves, which means that, so the impulse response is nothing but response of a system when the input is impulse. The practically speaking, this is, or the ideally speaking, this is how my input is there for delta m. But remember, whenever I will be developing any system, I should take care of a system when there is a sudden increase in my input. So normally I will be expecting some input to my system, but if there exists a sudden change for a smaller duration, so this is somewhere else. Practically I take it as a, the input is impulse, then how my system behaves, so that is what we call it as a impulse response. For example, if you take if you take, I am riding my vehicle, all the time my vehicle will be having some expectation that the roads are going to be very smooth and straight. So is that so? Sometimes we don't know, sometimes we may have a pitfall, right? Suddenly my vehicle will going to be jumped into that particular pitfall, again it will come back to the state of motion, right? So in such cases, for my vehicle is a system here. Suddenly, so the input was constant, suddenly there exists a one pitfall, again my vehicle will going to have short jump, again it takes a normal portion, right? Now, so for a small time period, my vehicle it got imbalanced. So even in such cases, in such cases, my vehicle should able to sustain such kind of inputs, right? So that's where we call it as we go for the putting a shock absorbers, which means that even if there is any shock or a sudden change in the input, it should absorb. That is the simple meaning over here. So in such cases, that is how my system behaves. That is what we call it as an impulse response. Or I construct a hanging bridge. Let me take an example of hanging bridge. So system is hanging bridge now. Okay, so this is my system. Now, every time I will be expecting that there will be a some speed, wind speed, so all the time. But suddenly in one day there will be a huge value or huge speed wind, wherein that we call it as a for a small duration there is a sudden change in my input, then once again I should study how the system behaves. So which means that all the time normally I will be expecting some input to my system if there is a sudden change. Okay, now while charging my mobile I will be expecting a constant DC current to my mobile phones. Suddenly there is a fluctuation in my current, one peak will going to occur which is for the small period. Again how my system behaves, all these are I call it as the system, the impulse input is impulse. For the short duration there exists some noisy input, so for which I will be obtaining a one kind of output, and that is what we call it as a impulse response. Okay, so normally my input will be there, so constant input will be there. So again there is a one more response that is called as an impulse response. Now when you now the system is getting normally a normal input plus again a another input impulse response. Now how the system should behave, mathematically speaking it is nothing but y of n is equal to x of n convolution with h of n. So h of n most of the times it is called as a impulse response, right? Now this is where we call it as the linear filtering method. Okay, so most of the times we are interested in the calculating h of n equal to y of n by x of n output to the input, because based on my output and input I will be always make sure that how my system behaves. That's what we call it as a system specifications, right? So this is how we go for performing a filtering operation for any of the inputs LTI systems. So mathematics, the when I say that filtering, behind the filtering the mathematics that is present is convolution operation. Okay, in one word. Okay, all these you have studied in your signals and systems, but to be more precise about the filtering process. So when I say that filtering process behind this, the mathematics that works is nothing but convolution operation. Okay, now what I'm talking about. So now I remove the filtering, which is nothing but a very simple word that is linear convolution. Okay, now you already studied about the linear convolution. What is that linear convolution? So linear convolution of a two time domain sequences is equivalent to the multiplication of these sequences, right? So this concept you already well known in the signals and systems as well as in the Laplace transforms. Many mathematical tools you come across with these types of convolutions. Okay, now for any system, if you say if I want to define my output y of n, I will be always defining my output y of n is nothing but convolution of my input with impulse response. And the same thing is true with respect to multiplication when I move from time domain to frequency domain. And here in calculation of y of n, so I will be much concerned about what will be the output length. So length of my output y of n is depending upon my x and h, which is nothing but if I assume that length of x of n is to be l and length of h of n is to be m, then the output y of n length will be l plus m minus 1. This is with respect to, I am once again clarifying you, this is with respect to linear convolution output, or you can replace with filter. Now the question is, I want to perform linear filtering. Okay, so you already performed in your previous semester, you already performed linear filtering, which is nothing but a convolution operation. Now I want you to perform linear operation, but you should use DFT technique. Okay, so there it was
Excuse me.
different. Yes, yes.
I'm waiting to join.
Okay, now we want to perform linear filtering process but you should use the DFT process, DFT operation. What do you mean by DFT operation? So DFT operation is nothing but DFT operation. See, when I say that linear filtering, it is nothing but a convolution operation. Okay. Now, if I want to use DFT method, so in DFT, what type of convolution method we have? We don't have a linear convolution. We have a separate another convolution, that is circular convolution method, right? We have a technique called circular convolution. Now, the point is very simple. If I want to use the DFT method, it is nothing but y of k into x of k. Y of k is nothing but the multiplication of two signals, that is x of k and h of k. So if I take IDFT, what we will going to get? Y of n is nothing is equal to, so it's a multiplication operation in frequency domain. So obviously this will be circular convolution operation, right? If I want to perform a linear filtering operation using DFT, it is nothing but circular convolution. Okay. Now the point is, what is the output length of circular convolution? So it is nothing but maximum of your two inputs, I x comma h, the length of x and length of h, whichever the maximum value is there, that will be your output strength, output length. But when you go for linear convolution, so this length is equal to n, this length is equal to L plus M minus 1, that is length of input x, length of input h minus the 1. So and this length will not going to match, is it not? The length of, so I am performing linear filtering. Linear filtering is nothing but I should get the output as good as a linear convolution. But using DFT means I will be performing a linear convolution. Instead of linear convolution, I will be performing a circular convolution. The point here is I cannot able to see the output with respect to same length. So now the conflict is the length in the output. By performing the circular convolution, I am not able to match my length linear convolution output length. So now the simple and straightforward is I need to make sure that the circular convolution operation must be done. The operation must be circular convolution, but the output should match with my linear convolution. That's it. If I'm able to perform that, then my job is done. So that's what I wrote here. The length of circular convolution and the length of linear convolution are different. Therefore, it is required to match the length of circular convolution required to match the length of circular convolution, so that we can obtain linear convolution output. So how do we do? So that will directly go to the problem and then we'll perform. So let me take this particular example, so that where you are supposed to perform linear convolution. Okay. So here onwards, you please remember, I can replace this anytime by using a word called linear filter. Perform linear filtering or perform linear convolution are one are the same. Using circular convolution or DFT method, once again one are the same. Now if you perform, you know already how you are supposed to perform the linear convolution in the traditional method. That is that you already studied in your signals and systems. You perform your the good old method, but now here you perform and you keep it at one side, and now you perform the same operation using circular convolution, but it should match the linear convolution method. Okay. That then only I can say that the method is DFT method, right? So here x of n length is, let me call this as L and let me call this as M. My output, I will be performing circular convolution operation, but the length must be equal to L plus M minus 1. So how do you do it? How do you do it? Just make sure that you match the input of x of n and h of n as per your output requirement. That's it. So what will be the output? What must be the output? length here. So I want linear filtering by using DFT method. By DFT method, which is nothing but I should perform a circular convolution, which means that the length must be equal to L plus M minus 1. In this case, the length L is equal to 4 and H is equal to 3 minus 1. That is nothing but 4 plus 3 is 7 minus 1 is 6. So my output should have 6, or else if I generally if I go for a circular convolution as my early step, that will be maximum of x length and h length, so that will be 4. The output will be length of 4, but this is not the correct way of performing linear filtering. So the correct way of performing linear filtering is nothing but the I should go for linear convolution method. A linear convolution output, but the operation that I'm supposed to perform is must be circular convolution. So here what I should do, you just append, you just match your input, you just match your inputs x of n and h of n with a balanced number of length. That's it. Balanced length means, so here output should be 6. You match the input x and h with the this particular length by appending zeros. That's it. So which means x of n is nothing but 1 comma 1 comma 1. So how many are required to match this length with 6? So two more values are required, which means two more zeros I will going to append. Now x length is also 6, and similarly h is equal to, I must be able to match this length to output length. So how many zeros I should append? 3 more zeros, so that the length will be equated to 6. Now input x of n and h of n length are matched. Now output, obviously it is going to match my output. So what operation I should perform? So that operation is nothing but circular convolution with h of n. Now you perform circular convolution operation. Just you take the input 1 1 1 0, 4 times 1 and 0 and 0. One second. So now how do you perform the how do you write the matrix? Once again, this value will going to occur first, then I'll shift entire values. This is 1 1 1 1 0. Then again take this 0 first position, then again shift this to the further values, that is 0 1 1 1 and 1. Again you take this 1 to the upper stage, and that comes first, and next 0 0 1 1 1. Again take this one upper side, 1 1 0 0 1 1. Again once again if you take, so this will be 1 1 1 0 0 1. That's it. So if you take once again, if you take this, so once again you will going to get the same uh, value here, the first column value. So no need to it will repeat, as it is a circular point or a circular operation. So once again if you take it back, so it is going to repeat the first column itself. So by that time you should think that I should end this shifting operation. Now I'll take the h value, h value 1 1 1 0 0 0. Now if you perform the circular convolution like this, so this is nothing but a matrix multiplication operation. This matrix has to be multiplied and perform the operation, multiplication operation, and get the values. So what is the output here? uh, just multiply, and please let me know the output here. So it is nothing but 1 into 1 1. I think rest of the values 0 into 1 is 0, 0 into 1 is 0, and rest of all 0. So therefore 1 is the only value that comes first. Then second value is 1 into 1, again 1 into 1, it is going to be 2. Then rest of the values are going to be 0. So here I'll write 2. So next 1 into 1 plus 1 into 1 plus 1 into 1, that is going to be 3, and rest of the values are going to be are multiplied with 0, hence 0. So again 1 into 1, 1 into 1, 1 into 1 3 times, so therefore this is once again 3, and once again 0 into 1 is 0, 1 into 1 and 1 into 1 only, and rest of the values are 0. Therefore this comes to be 2, and last value is 1. So just cross verify your my answer by performing on your own. Okay, so this is length, this output is nothing but y linear convolution output. But in what way we perform? We perform circular convolution. So this is nothing but your the linear filtering method, that is 1 2 and the last value is 1, right? So this is the linear filtering method. So this is very simple and straightforward. The problems are very simple because you already solved. The thing is, you need to understand the concept of linear filtering. So many of the times in the question paper, so we will be giving a question like perform linear filtering of given two sequences, okay, using DFT method. So that's what the question you may expect. In that particular question, during that you should understand that, so the linear convolution or the linear filtering is nothing but a convolution method. But you are not supposed to take the approach of linear convolution, that you already did it in signals and systems, but you are supposed to make use of the DFT technique. What is the DFT technique? So DFT technique is nothing but y of k is equal to x of k into h of k. This is DFT, discrete Fourier transform, right? For when two input sequences are given. So in time domain what happens? This is in frequency domain. In time domain what happens? In time domain it is nothing but a the convolution. What type of convolution? Circular convolution. The reason, the one of the very important reason is linear convolution length and the output of linear convolution and the output of circular convolution length will not going to match. So that's what in this example we saw that how to match the length of input x of n and h of n, so that the out even if you perform circular convolution, the length will equal to linear convolution. Not only length, the output also equal to linear convolution itself. Okay, any doubts here? Okay, assume that the input x of n sequences continuously you are getting 1 2 1 3 4 5 1 2 3 2 continuously like this. The your system for your system, the continuously I am feeding the x of n values, but and there exists some impulse response values. Now I am supposed to perform or filtering method in such cases. Now I need to perform the filtering operation for the system. Now the system is getting, because in real time I cannot say that I am going to get only this much values, or I am going to get only 4 to 5 values or 6 values. I don't know, I will be getting the series of input in the to the system x of n, and that value is supposed to be the series value of x of n are supposed to be perform the operation called circular convolution or linear convolution. In general it's a convolution operation. Then with h of n, then I need to get the y of n output. In such cases, how do you perform? How do you solve this? So in order to that's what we call it as a the input are long sequence. Okay, when the input is long sequences, how do you perform the filtering operation? So that is what the next topic. uh, the next topic, filtering of long sequences. So there are two methods to solve this. So one is overlap save method and another one is overlap add method. So it is assumed that It is assumed that, so once we have a x of n, so as I told you, x of n will be having long data sequences like this. So 0 1 2 up to l minus 1. So in such cases what we do is we divide. Okay, we divide this length, say for example l. So all the input datas are going to be divided by some length l, and we take this value. Now I call this as the first sequence of x of n, and I perform a circular convolution with h of n. Now I am going to get some one output y of n. Similarly, once again, I'll go with the next length L, another L sequences. Then I will be getting the X2 sequences, and then I convolve that value into H with respect to H of n, and then again I'll going to get a Y2 of n. Then again I'll going to take the final y of n with the help of y1, y2, y3, and so on. And that particular method depends on either I'm going to make use of the save method or add method. That's it. So here in both the methods, your input, which is long data, are going to be divided into small blocks. That is first important point, and I will be calling that length of the block size is to be l, the length of the input, that what we are trying to divide, and that length we are trying to be called it as length l. And h of n, as usual, we will be calling it as m. Now intermediate output, as I told you, I will be performing the convolution operation. Obviously I will be performing a circular convolution. Now this is nothing but an intermediate output. How many point DFT that you are trying to take, whether you are trying to take a 5-point DFT or 4-point DFT, that is what the n is going to be treated as. Okay, now based upon the n, now here what is to be decided is, so I will be in the examination, or you will be given with to go with assuming 5-point DFT sequences or 9-point DFT sequences or 6-point DFT sequences, and then you should decide how many blocks of your input are supposed to be divided. You have an input x of n. Based on that, you should find out l value, that is how many how many input data are supposed to be divided. Then obviously m is given. Say for example h of n will be having a sequence of 4, then 4 minus 1. Now each l value x of n should be divided in such a way that 4 minus 1 is 3. When I shift it here, 5 minus 3 is 2. So which means length of 2 sequences I should take. So first 0th sequence, first sequence, followed by second sequence, third sequence, fourth sequence, and fifth sequence. 2 sequences I will be taking. Then I will be going for performing the circular convolution with h of n. So this is how it is going to be performed in overlap add and overlap save method. First we will see overlap save method technique. Then we'll move for the overlap add. Just for this day I will be restricting my explanation for overlap save method. Then we take a one example, then that's where we're going to end up the session for the overlap save. In the next class I will be teaching you the overlap add method. That's it. Okay, very simple and straightforward, guys. Once you understand how to divide the input sequence, rest is once again a circular convolution operation itself. Now assume that you have a x of n. Assume that you have a x of n sequence. This is x of n, the long data sequence. Okay, now I will be dividing this x1 of n, x2 of n, x3 of n, and so on. Okay, depends on total length. So total length of each smaller sequences, that is n values. Now what I should do? Perform the first sequence x1 of n. X1 of n, I want to divide this with value, some l value. This l value, apart from that, you need to, in order to match the circular convolution length, what we will be doing is To match the length, I will be adding m minus 1 zeros initially for the first block. This is for only for first block. Okay. Second block onwards, for the second block, okay, I will be taking a second sequence x2 of n here from the from x of n. I will be taking a x2 of n, for which I will be adding appending m minus 1 previous values. This value I will these m minus 1 values are going to be added for x2. Similarly, x3 I will be taking from the x of n, and for this x3 I will be adding m minus 1 values from previous block. Let me assume h of n is containing 4 values, where this value I consider this as m minus 1 means 3. Initially I will be appending 3 zeros here. Next, three values, the last three values of x1 of n is appended first for next x2 values. Okay, then the fresh l number of values are going to be added to x2. So similarly, last three values of x2 of n is appended to x3 of n. Initially, first three elements of x3 of n, the next l elements are going to be added from the your x of n values. Okay, now then finally what we do is we perform x y1 of n. What is y1 of n? Y1 of n is nothing but I am having x1 of n, a circular convolution with h of n. Similarly, I will be performing y2 of n. Okay, similarly I will be performing y3 of n. So finally, when I want to have y of n sequences, finally I want to have y of n sequences, I fetch y1 of n. I fetch y1 of n. From this y1 of n, I will discard first m minus 1 samples. In the previous case, I took h equal to 4. So where I added m minus 1, that is 3 zeros here. So that is added. So I remove it at the end of the output. Again, m minus 1 samples are discarded from y1 of n. M minus 1 samples are discarded from y2 of n. M minus 1 samples are discarded from y3 of n, and it continues. Okay. So we will see this operation with one good example here. With this, probably will come to know the much better understanding of overlap save method. Now find out the y of n filter of a filter whose impulse response is h of n equal to 1 comma 1 comma 1, and input is equal to x of n is this, using overlap save method. Okay, using overlap save. Now assume you need to decide how many length you need. So you need to decide about, so this length, how many length you should take, x1 of n, x2 of n, x3 of n, and so on. How do you decide this l value? I need to decide this l value first, right? How do you decide? I already know that h of n is nothing but 1 comma 1 comma 1. So this is m value. M is 3. So as I told you, the length should be equal to n is equal to l plus m minus 1. Now I must also tell you that how many point DFT you are supposed to use, and let me assume the value of n is equal to 5 point DFT. Okay, here I will put 5, then l I should calculate, plus m is how much? 3 minus 1. So 3 minus 1 is 2. Again, if I take the l on the left hand side, so the l will be equal to 5 minus 2, that is equal to 3, which means that block of 3 input should be divided. That's it. So x of n is going to be divided in such a way that, so x of n is equal to, so here 3 minus 1 0 1 3 2 0 1 2 1. Now I need to divide this a block of L. I got to know by calculation method, I got to know the L should be equal to 3. So this is one block. this is second block. Okay, three elements. Then the third element, the third block, l equal to 3. So this I will call it as x1, this I will call it as x2, and this x3, and I left with one more, so I must take care of this one also, that is x4, right? So now what is the value of x1? X1 is nothing but I need to match the length, as I told you, right? I need to match the length. So how many zeros I should append? M minus 1. Look at the previous slide. I am trying to append in the first stage itself. I am trying to append m minus 1 zeros. M minus 1 means here m minus 1 is nothing but how much? This is 3 minus 1, that is 2 zeros I should append. So first x of in signal will be 0 comma 0. Then as usual I will be taking this entire value, right? I will be taking 3 minus 1 0. Okay, now x2 of n I should take. X2 of n is equal to the previous two values of x of n, that is minus 1 comma 0. Now the fresh values of x2, that is 1 3 2. Then again x3 of n is equal to the previous two values, that is the m minus 1 value, that is 3 and 2. Now the fresh values 0 1 2. Then finally x4, yes, as usual I must take the previous two values 1 comma 2. Then the fresh values I left with only one, so but I need to match the length. I will append zeros. How many zeros I should append? So totally 5 values, I should append 2 more zeros, that's it. So I got x1, x2, x3 and x4. What is the value of h of n here? H of n is equal to 1 comma 1 comma 1. So I am going for circular convolution using but the operation must be linear convolution operation, so that I should perform I should append 2 more zeros to h of n, right? 2 more zeros to h of n. So now as usual perform the convolution. Y1 of n is nothing but x1 of n, 5-point circular convolution of h of n. Hello? Y of n is equal to look at this 3 comma 2 comma 2 from first y1 of n, next 0 4 6, then 5 3 3, then 4 3 1. So this is my final output. Look at the length. 3 plus 3 6, 6 plus 3 9, 9 plus 3 is 11. Look at the actual input, the length, this 1 2 3 4 5 6 7 8 9 10. So length of this is 10. Okay, length of this is 3 minus 1. So how much length you should get? 10 12, right? So somewhere else 1 2 3 4 5 6 7 8, oh 9 plus 3, correct, 12. This is 3 plus 3 6, 6 plus 3 9, 9 plus 3 is not 11, 12. If you observe carefully, this is nothing but the length is matching with my linear convolution. Now it is as good as linear filtering, that what we perform. So this is the final output with respect to overlap save method. Okay, any doubts in this problem? I'll come back to the Google chat room. If you have any doubts, please let me know.